Hello, everyone. Welcome to the latest installment in Precision Roll Grinders webinar series. Today, the webinar is the case for precision grinding of calendar rolls on linerboard machines. It's a very specific topic that we wanted to cover. Container board continues to be a growth market in the paper industry. It's a very important market in the paper industry, and we wanted to take some time to speak specifically to that. As always, we appreciate you spending some time with us this afternoon. Right now, everybody is currently muted, but if you do have a question, there's a chat function that we encourage you to use at any time. We can pick those questions up, and at the end of the webinar, we'll go ahead and unmute everybody so that you can ask questions in person too, if you care to. So we'll go ahead and get started. So I've heard this, and I've probably been guilty of saying it because I did spend the first half of my career making paper primarily in linerboard paper mills. It's just linerboard. I don't need that level of precision, particularly around calendar stack rolls. The answer is yes, you do. Linerboard machines are very unique, but they certainly need first and foremost strength. These are packaging grades. STFI and ring crush are critical. Mullen is still tested, used to be a more prevalent test, but the cross-directional strength tests are more prevalent now. Caliper variation directly correlates to strength variation. We'll talk about that a little bit. Just good caliper control, building a good reel, reducing spool losses at turn-up, improving winder runability, improving the convertibility at the corrugator. Caliper variation tends to manifest itself in any of those areas. We'll talk about longer calendar roll run life. When you start at OEM specifications of 2/10,000ths of an inch on roundness, your roll has more of a chance to run longer because of just the geometry behind it. The wear on a roll is proportional to how much deformation is in that roll. So when you start with a little more deformation, the wear tends to escalate faster, and it's not a linear curve. It's actually more like an exponential curve. So the washboarding effect that we all see on country roads. Also, linerboard machines need best-in-class smoothness. Although it's not considered a printing and writing grade, linerboard is certainly printed on. Your crowns need to be in control on your variable crown rolls, on the king rolls in your calendar stack, and then some queen rolls in your calendar stack. In many cases, you can eliminate the CD fixers, we call them, cow coils, air showers, water, those types of things. So we'll dive into some of the specifics here. Let's first talk about strength. Just mention the reason, the OEM roundness specification for chilled iron calendar rolls is 2/10,000ths of an inch. There's good reason for that. And it has to do with a number of issues, but the first we're going to talk about is caliper variation. The picture on the left there is actually a series of 6 of the carbon paper nip impression strips, but that were run through a calendar stack in a machine direction, and you can see the barring or the machine direction variation in that calendar stack. Quite often you can see it on paper machines visibly over time, and that has a dramatic effect on that sheet of paper. Not only can you build reels that look like the one here in the middle, that end up causing trouble with spool losses downstream on the winder, and as we mentioned earlier, on the corrugator. But there's evidence out there. There's a study that was done by FP Innovations that showed that pretty small caliper variation, around the 10 micron range, can cause strength variation of up to 20%. The strength was measured in tensile, but in paper making, tensile is the foundational test for all others. Tensile does correlate to ring crush and to STFI, and correlate some to tear. But anyway, the breaking length was tested. So that machine direction variation Uh, Often you can't see, obviously when you're running, you can't see it in the rolls because of the speed of the rolls are turning, but you can see it in the reel. And if anybody's made linerboard long enough, they've seen a reel that starts to build like this. So barring is something that's very important, very critical. You have to remove barring. Quite often, rolls come back from your grinding vendor and they don't look like they have barring in them. But very quickly, once they start running, you can start to see it. You can start to see it in the sheet. You can start to see it in the reel. You have to grind through that. And you have to get to that 2/10,000ths of an inch of roundness to truly provide the correct start on your linerboard machine. So real world, what's that mean, real world? Again, we're making linerboard. If it runs on a corrugator and it goes through the winder without breaking or causing any trouble or tying up in between rolls on a set, then what's the problem? Well, the problem is that you're managing that paper machine in some cases to strength. And if you can reduce the variation in strength, is there the possibility to shift downwards in basis weight and either speed up out from under it or take fiber out of the sheet? Are you steam limited? There's a number of issues obviously around each individual linerboard machine. Well, this is a real world case study where STFI variation improved 54% with calendar rolls that were ground precisely, ground to that 2/10,000ths of an inch in roundness that Beloit and all the original OEMs specified to. In this case, it allowed for a basis weight reduction of 2/10ths of a pound per 1,000 square feet. And there's potential speed increase there. You're not drying as much mass. There's potential fiber cost reduction if you take it out. What allowed that to happen was an actual STFI variation reduction of 3.7 to 1.7. That 54% improvement that led to the basis weight reduction, 2/10ths of a pound is conservatively $500,000 a year in this mill. So again, the graphic on the right shows the actual data that was generated by FP Innovations. It's something to consider when thinking about your calendar rolls, is that there could be a direct correlation to the variability you're seeing in your strength on that paper machine. One of the old rules of thumb of calendar stacks, particularly on linerboard machines, was that you can't fix what's happened necessarily prior to the calendar stack entirely with the calendar stack, but you can mess it up with the calendar stack if not done correctly. So the calendar stack is designed on paper machines and even on linerboard paper machines for a specific reason. That caliper profile is very critical, not only to the downstream runnability and convertibility of the paper, but also to the strength that you're building into that sheet that you've spent the entire time on the paper machine building. We certainly want to maintain it or improve it in the calendar stack, not make it more variable. The second piece of why there's a 2/10,000ths of an inch OEM roundness specification is just runnability. Again, we show the same pictures. The barring in the roll, you get a reel it's building like this. You end up having, a couple of inches of paper at the bottom of that reel, right on top of the spool, that really can't be run through the winder. The spool's sent back up to the dry end, and that's run back off into the dry end pulper. There's big economics in being able to eliminate as much of that as possible. There's big economics in making sure that your winder can run efficiently. Linerboard machines are pushing tremendous speeds these days. So they're being built tremendously wide and they're running really fast. And again, a rewinder or a winder's got to run roughly 3 times faster than a paper machine. So if the linerboard machine's running 2,500 feet per minute, that winder's got to spool up to 7,500 feet per minute in between sets. Sets need to be kicked off efficiently so that you're not getting behind on the winder. All those efficiencies really have a big economic impact on the runnability of a linerboard machine. So if there's any way to reduce spool losses, to improve winder runnability, to possibly reduce sheet breaks at the dry end. That variability coming out of the calendar stack is also variability in the draw to the reel. Are there sheet breaks that are happening, mystery sheet breaks that can't really be pinned to any other reason that you can see on the paper machine? Again, the reason for calendar stacks being designed on linerboard machines, a reason for the specification to be as tight as it is. So again, a real world case study. That's hard to say sometimes. A mill that improves spool losses by 250 pounds per reel. 250 pounds is approximately 12 seconds of runtime on this paper machine. Linerboard machines very typically now run 50 tons an hour, plus or minus. So it does not take long to build 250 pounds. And you can see the difference in the reels. The reel to the right's not perfect, but it is a lot better. 250 pounds per reel, about 1,000 tons per year. It's hundreds of thousands of dollars. This mill, along with being able to reduce spool losses because there was not that machine direction variability, so when they turned it up much cleaner. Their winder efficiencies improved as well. Now, we realize there are a number of levers, probably arguably hundreds of levers you can pull on a paper machine, and calendar stacks is certainly one of them. We feel it's a very critical one. We don't want to be so bold to say that everything gets fixed just because you get your calendar stacks ground properly. However, why not eliminate one of the bigger critical pieces, unit operations on your paper machine as a contributing factor to the variability of your paper machine? Let's make sure that that's eliminated so that you have a better opportunity to find perhaps where other things are happening. And we'll talk about how we can identify that, how we set that up, and statistically work with you to analyze data and to ensure that we're doing the right things. Again, real world case study. Another very important reason that OEM specification on calendar stacks is so tight is because of this graph. We mentioned it earlier, but runtime is important. If you're running your calendar stack 6 months before they start barring and then you have to take them out and replace them, can we push that to 9 months? Can we partner to push that to a year? We've seen extreme cases where it goes from 6 months to 18 months, 6 months to 24 months. And it's really in the geometry. It's in the physics of what's happening on a dry end of your paper machine. Again, the wear on a chilled iron calendar stack roll is a function of the deformation of that roll. So if you start at 2 10,000ths as opposed to 8 10,000ths, let's say, and 8 10,000ths, I think in the minds of a lot of people, that's tighter than 1 thou. Gosh, that's good. Well, no, it's 4 times what it should be, quite frankly. And the reason being is that within 6 months, because you start with more deformation at 8 10,000ths, let's assume your regrind points to that orange line. In 6 months, you've reached a wear on that roll that dictates that it needs to be changed, as opposed to starting at 2 10,000ths. And even at 2 10,000ths, they do wear over time, but they wear much differently over time. And it pushes it out to, in this case, 15 months. So again, it's not, it's a function of the gravel road that washboards over time. It's the same type of principle. So what could longer roll life mean for your linerboard machine? If you're only having to change calendar stacks every 12 or 18 months as opposed to 6 months, how does that free up not only the available crane time, let's say on an outage, but the available time of those mechanics and those craftsmen that are there doing that? Are you certainly improving safety by not having to change rolls as often and having to load them and package them and ship them and all those kind of things. So again, another aspect to consider when thinking about the calendar rolls on a linerboard machine. So if we wrap all this up, again, real world case study here. and we'll just outline some of the things that we're seeing. The caliper CD variation went from 0.6 to 0.3. STFI variation, as we've mentioned before, went from 3.7 to 1.7. Sheffield smoothness improved from 380 to 365. Calendar roll life went from 6 months to 18 months. Cow coil and air hoses, those CD fixers that we talked about, were turned off. And the crowns were in control. Quite often, we'll see crowns that are maxed out, if you will, or the controls that are bumped up against the edge of the control limit one way or the other. And like any control on your paper machine, whether you're controlling a basis weight valve or a steam valve or a consistency transmitter, consistency control valve, or whether it's a controlled variable controlled roll, you should be in a mid-range for that control. So that's another example of how your roll grinding supplier should be working with you to optimize that unit operation. Bottom line in this mill was almost $1 million a year in savings. And again, feel that's conservative just because of the economics behind producing 50 tons an hour of product. That sells, I think, somewhere around $600 or $700 a ton now. So again, real world economic return on an investment. All too often, roll grinding and roll services as a whole are considered a line item maintenance cost. We would ask you to seriously consider the fact that it should be an investment. You should be expecting of your roll grinding supplier, your roll grinding service partner, that they provide a return on that investment. Quite often on linerboard machines, which are large paper machines, the cost of that roll service is at a level that would otherwise be capitalized, as opposed to just being a maintenance expense. So again, we'd encourage you to take that return on investment capitalization type of mindset with this, as opposed to well, it's just a cost that's necessary, and it's a necessary evil. We just need to go to the lowest cost and get it done. Well, if I back up one, that lowest cost could very likely be at 10 thousandths or 10 thousandths or a thousandth in roundness, as opposed to the specification that's really needed at 10 thousandths. So at the end of the day, what's it really cost? The other aspect of calendar roll maintenance is everything associated with that roll aside from the grind. The rebuild of controlled crown rolls, the bearing inspection, seat grinding and replacement, NDT, new journals, leak testing, all the things that you see here. Just encourage you to quiz your roll service provider to make sure that they're bringing you world-class maintenance. Again, before and after here, these rolls are under tremendous pressure. They work in an environment that's not necessarily conducive to bearings and grease and that kind of thing, particularly as you work up the wet end of the paper machine, but even at the calendar stack. So, roll life is also tied into mechanical and maintenance excellence. So at the end of the day, how do we do this? Well, we'd encourage you again to expect a promise to provide real economic value from your roll grinding and service provider. One of the things that Precision Roll Grinders does, or the thing that we do with the application engineering group, is design an experiment with our partners. What are we looking at? What's critical on your paper machine? What are the key performance indicators on your machine? What data can you give to us? Because I know, having grown up in a paper industry, the technical departments that were there 20 years ago, the process engineering levels, even the project engineering levels aren't there. There's so much more that is expected out of the assistant superintendents and production managers now. Plug into your vendors to provide some of that process engineering. And again, Precision's got an application engineering group that comes in and does this. Just shove the data our way. Let us take a look at it, analyze it, implement a plan for variation improvement, and then make sure that it's being controlled over time. It's really a Six Sigma rigor approach of design, measure, improve, I'm sorry, design, measure, analyze, improve, and control. And we've done this across a number of markets as well, even outside the paper industry. So the synergies that have been learned in other markets can be brought to bear on the paper industry, and specifically linerboard machines, and really get it to the point where there could be a predictive equation generated that will show a partner what to expect over time. Yes, we should be able to expect 12 months out of these calendar stacks while maintaining A, B, and C with respect to your quality and your productivity. Well, we're in a virtual world, right? It's kind of tough to do that. It is tougher, but it is not impossible. Data is obviously transferable across the internet. You know, we've worked with some customers on troubleshooting virtually with pictures and video. You know, and again, statistical validation is something that we can do and put back in front of our partners to say, okay, this is what we're seeing with respect to A, B, and C. This is just an example. You know, we work with partners to customize the return on investment calculations. We also realize that there are numbers that you're not going to feel comfortable sharing necessarily. So we can build this with you, and you can plug your own numbers in to really truly see what the cost of improperly ground rolls, and in this case specifically calendar rolls, is doing to your operation. And this is just to repeat the process. You know, there's data there. You know, your mill is very likely measuring cross-direction caliper variation. It's measuring machine direction caliper variation. You're getting smoothness measurements in the lab. You know how many dry end breaks you have per month, and for how long. Now, all these things that should be analyzed to ensure that that investment you're making in calendar stack roll grinding and service is paying off. So that's the webinar. We'd like to try to keep them to about 20 minutes. I ran over by 10%, 22 minutes, but please feel free, if you've got questions, to reach out to us, to reach out to your local account manager, reach out via the website, whatever means is most comfortable for you. And you know, allow us to have a conversation and work towards optimizing particularly the calendar stack on your linerboard machine. So with that, if there are any questions, certainly entertain it at this time. There's one that came through. Do you handle rebuilds on all CC rolls? Yes, we're capable of handling any rebuild on any variable crown, controlled crown roll. We have decades of history doing that. So we are another option outside of the original equipment manufacturer. And if you have specific questions, again, I'd encourage you to reach out and do that. Any other question? There's one more. How long do the studies take? With calendar rolls, they don't take very long. Generally, there's data that's already residing in a platform somewhere in a paper mill that has those variables that we talked about earlier: cross direction and machine direction, caliper variation, moisture variation, basis weight, you know, lab tests on smoothness and strength. So really, we need to determine together what period of time we want to look at before and after. Once we see a roll, we've got an entire history from that point forward on what that roll looked like after it came out of your machine, before it was ground, what it looked like after it was ground, all the maintenance and mechanical work that was done on it, even machining work. So in many cases, it's within 4 to 6 weeks after rolls are installed, we have a pretty good picture of what's going on. We obviously want to track it over time with our partners, because we do want to bring that return on investment while increasing the roll life at the same time. So they're pretty quick. Okay, any other questions at this time? Well, we certainly appreciate the time that you've spent with us today. And please look at the website. We've got upcoming webinars coming up. We'll send invites out specifically to folks the best we can as well. And again, any questions, please reach out. We're always open to talking to you about how to improve your process through precision roll grinding and roll services. Have a great day, and we'll talk to you soon.